Hello, I'm Roy Thompson, author of Basic Signalling Principles and Associated Circuitry Presentation. This is where the fun starts. Putting principles learned and understanding of straight line diagrams into practice. Section 3 provides a progressive introduction to active circuitry in use today. As with all sections, a video presentation covers all of the learning material, and an e-book provides the information in written format. In other words, a workbook. The workbook also contains self-assessment questions and answers to check the progression made. If you're not already aware, the complete package comes at a very low cost and is a bonus. I'll explain this later. If you like this video, please hit the thumbs up button and subscribe below. Let's look at the content covered in this section. Already being aware of aspect sequence, we start by looking at the relays involved in controlling aspect changes. We look at the circuitry involved in the control of the HR, red to proceed. Double HR, single yellow to double yellow. DR, yellow to green in 3-aspect signalling, or in this case, double yellow to green in 4-aspect signalling. Before looking at how the signal itself changes aspect, we first look at signal ahead proving and its introduction of the ECR and ECPR relays. Now we're able to cover the circuitry involved in lighting the red aspect, single yellow aspect, double yellow aspect and green aspect. Next is the lighting of the lamp itself, covering the step-down transformer, double filament lamp, main and auxiliary filaments, and the EPR, what happens when the main filament burns out. And we then look at the ECR, covering why it is a slow to drop relay, why it remains energized when the main filaments burn out, and why it drops if no filament is lit. The signal head lamp proving circuitry is then covered, showing how the ECPR is operated and how it holds the HR down if no lamp is lit in the signal head. Back to the EPRs in the signal head, we look at the circuitry involved in the proving of the main filaments lit and how, with the use of the EKR and EKSR, a main filament blown is identified and replaced. A self-assessment test is then made using the workbook and answers checked to see if in any areas require revisiting. Moving on, we go into some depth into controlled signalling circuitry. However, the building of the circuits evolves to a semi-automatic signal, and we then need to introduce the TSR circuitry, which fully explains how the signal becomes fully controlled, ensuring a form of action is taken for each signalled move. Here we can see this in its video format, giving a demonstration of how video presentation is used throughout the sections. Let us look at the TSR circuit and see how it achieves it. Let us look at the situation where we wish to send a train through the section. The lever is in the frame, normal, and therefore the signal is red. Let us look at the TSR circuit at this point. A track is the track entering the section. There is no train in the section. A track relay is up, energized. Its front contacts will therefore be made. The lever is normal, so the HR will be down. The current will flow through a TSR, which will energize up. The circuit shown in red is known as the pick path. If we follow the green route now, we can see that there is a second path to ATSR. First through ATR proving A track clear. Remember the HR is down at the moment, so number 2 signal is at red. Then through ATSR's front contact, this is known as the stick path. When the signaller reverses number 2 lever and we follow the 2 HR circuit, we can see that if all conditions, track circuits up and the points in their correct position, are met with the reversal of number 2 lever, and a TSR is up, it will pick, and this will allow a proceed aspect on number 2 signal. If we look at the TSR circuit, when 2 lever was reversed and 2HR was energised, we lost the pick feed to the TSR, shown by the red line, only now reaching the back contacts of 2HR. The green line shows that the stick feed still remains. As its name suggests, the TSR sticks up. When the train passes signal 2 and the front wheels drop A-track circuit, both 2HR and TSR will drop. Note that the red feed the HR and both red and green pick and stick feeds to the TSR stop at the front contacts of ATR, which is now down because the train is occupying it. Number 2 signal, as expected, goes to red, and at this stage TSR remains down. As we have seen before, at least one of the track circuits will be occupied whilst the train passes through the section, but it's worth looking at the TSR circuit when A-track becomes clear. If the signaller has left the lever reversed, the pick feed is stopped at the N band. The stick feed is stopped at its own front contact because the TSR remains de-energised. Here we can see the train passing through the section, but if the lever has been left reversed, TSR is still de-energised. This prevents the HR becoming energised, therefore 2 signal remains at red when the train clears the section. In order to send another train into the section, the signaller must place 2 lever to normal. The TSR picks and sticks. And if 2 lever is now reversed, we can pick 2HR and change the signal to proceed. Signal 2 is now a controlled signal. Approach locking is next, with the introduction of the GR replacing the HR and approach locking proved, ALSR up, before the HR picks and gives a proceed aspect. Approach locking is explained using the mechanical interlocking principles and any change of aspect viewable for multiple aspect signalling. The principles are then converted to diagram. Position-like junction indicator circuitry covers how the lamps are lit, in this case for route 1 and route 2, and the circuitry involved improving enough lamps lit before a proceed aspect is allowed by the use of the UECR. Standard indicators in almost all cases these days are fibre optic. But just as a matter of interest, the multi-lamp indicator, often referred to as the theatre type indicator, has been included showing how, and in diagram form, these are lit. This is followed by a detailed explanation of how the stenciler type indicators are wired. Position light shunt signals are again, in most modern installations, operated using fibre optic, but again we've covered this using the older style format. As well as showing the operating diagram, we have covered the indication circuit, which is an example of polarised circuitry operating the RGPR, the red signal proving relay, and the off RGPR, the off signal proving relay, when polarity is changed. Finally, we cover the circuitry involved in the position light subsidiary signal and the circuitry involved in the operation of the older style of banner repeater signal. Then it's back to the workbook to carry out another self-assessment test. That is the content covered in section 3. The introduction and content videos, section 1, basic signalling principles, and section 2, signalling diagrams, sketches and plans, can be accessed via the links in the description box below. The remaining sections cover track circuits and points, and videos like this will detail the content shortly. 5 ebooks and 5 videos giving a firm foundation for learning railway signalling engineering for just £15 plus VAT. And then there is a bonus. You will also receive the ebook Assistant Tester Mod 5 for free, which is downloadable when you purchase Basic Signaling Principles and Associated Circuitry Presentation. To purchase Basic Signaling Principles and Associated Circuitry Presentation, click the link in the description box below. It is payable via Visa, MasterCard or PayPal, and access is then immediate. If you like this video, please hit the thumbs up and subscribe below, and I hope to be in contact soon with more detail. Access to more information will also become available in Basic Signaling Principles and Associated Circuitry on Facebook, and can also be accessed via a link in the description box below.